Good evening, everyone. Guys, am I audible? Yeah, thank you. So, in our last session, we were discussing with how do we write some security policies on the ASA firewall. We have seen how administrator can control LAN computers from accessing internet based on certain services. So you can say only some services will be accessible to the end user, not all the services. Then you have also seen if you have to give exception, right? Maybe to one of the manager IP or someone, if you have to give full permission, how exactly we can write the configuration. We have also seen that. And then we were also discussing about time-based policy. That is, if you have a requirement that internet should not be permitted, right? Internet should not be permitted all the time. There should be a restriction on the timings. You can also do that. You'll also be able to say internet will only be accessible in so and so time. Then we have also seen how do we block end users or our LAN network users from accessing all the websites, right? And then, as we were discussing, uh, not only blocking end users from accessing some websites and all, right? You should also authenticate the users, right? So when a user is trying to access internet, firewall should ask the user, right? Firewall should identify who is this user. Only after proper authentications, we'll have to permit them to access internet. Now, why such a requirement would be there? Why should we authenticate the users before permitting them internet access? What would be the reason? So, guys, why should we authenticate users before permitting them to access internet? So, let's say in our yesterday's security policy, we are saying that if you do not want to permit internet, right, to a specific computer, you can write a policy. So yesterday we have done that. We said for a specific IP 192.168.10.10, we said internet will not be sorry, no, not internet. Email access will not be permitted. We have blocked SMTP access. Right now, in the same fashion, if you don't want internet to be permitted to some computers in the network, can we do that? Can we say for so and so IP addresses, internet should be blocked? So we can define internet should not be permitted for some IP addresses. Now, what happens if user changes the IP address on the computer? You said for 192.168.10.10, internet should not be permitted, right? So the end user has come to know that if there is 192.168.10.10 IP address on their system, internet is not accessible. But if 192.168.10.20 or 10.30 IP address is there on the computer, internet will be accessible. So once the end user knows this, can they try to change IP address on the computer and try to access internet? So it is possible. So once the end user knows to which IP address internet is permitted and to which IP address internet is blocked, they can try to change the IP address and start accessing internet. Now to restrict this, what can we do? Along with writing uh, permissions based on the IP, right? You can also enable authentication. Now, once you enable authentication, before accessing internet, end user has to type their username and password, right? Only after successful verification, end user will get access to internet. So in such condition, if a user does not know what is the user ID and password for authentication, whatever IP address is there on their computer, right? So whatever IP address is present on the user computer, if end user does not know what is the user ID and password required for authentication, will they be able to access internet? So if they do not know what is the username and the password, they will not be able to access internet, right? So that will be a much better approach, right? Instead of writing policies based on the IP address, we can say we will provide user ID and password to only those users who should be accessing internet, right? So except those few users, others will not have any username and password. And without providing a user ID and password, user will not be able to access internet, right? So what we can do is start configuring user authentications on the firewall, right? Now, when you speak about authentications, in general, you have two types of authentication, right? So in general, you have two different type of authentication methods, right? Guys, I have not yet shared my screen. I'm discussing the concept. Okay, so don't worry. So when you speak about the authentication part, there are two different type of authentication methods. So let me put it here on the notepad. So the first type of authentication is something called internal authentication. So the first type of authentication is something called internal authentication. Right. So here we speak about internal authentication, the username and the password. So whatever user accounts you are going to create, all those user accounts will be saved or will be stored on the firewall itself. So the user information, right? Whatever user information you have created, your user IDs, passwords, and all, everything will be stored on the firewall. Right? So whenever you try to access internet, firewall will give you a prompt asking you what is the username, what is the password. You type the user ID, you type the password. So once the username and password is given, firewall will check if this username and password is correct or not. If it is correct, firewall will let you access internet. And this user ID and password verification happens locally on the firewall. Right. So in the internal authentication, you will have all the username and passwords stored locally on the firewall itself, right? And user ID password verification happens locally on the firewall. So is that clear, everyone? Okay, so internal authentication, you will have user ID and password stored on the firewall itself, and authentication happens locally on the firewall, right? Then there is something else called external authentication. So in external authentication, instead of saving the user ID password on the firewall, right? So in external authentication, you will have these details saved on a external server. So all the user ID and password information will be saved on a external server. So here, this server can be a Radius server, it can be a TechX server, or you can call it as a TechX Plus server, right? It can be a Active Directory LDAP, right? It depends on the firewall capability. What all servers can the firewall speak to? But in short, the user ID and password information will not be stored on the firewall. User ID password verification will not happen on the firewall when you go with the external authentication, right? In external authentication, you will have username and password information stored somewhere else on an external third party server, and also verification will be happening somewhere on the third party server, right? Internal authentication, data is stored on the firewall. Authentication also happens on the firewall. So is the difference clear between internal authentication and external authentication? So guys, are you clear with the difference between internal and external authentication? Okay. So here when it comes to where do we use internal authentication or where do we use external authentication? If you have to maintain a small number of user accounts, right? Say you have to maintain a very small number of user accounts, like say 5 or 10 user accounts, then you can go with internal authentication, right? So if you have to maintain a very small number of user accounts, you can go with internal authentication. But if you have to maintain a large number of user accounts, let's say 50 user accounts or 100 user accounts or even more than that, then in that condition, it's always recommended to go with external authentication, right? So if you have to go with a small number of user accounts, go with internal authentication. But if you have to go with a large number of user accounts, it's always recommended to go with external authentication. So is it clear, everyone? So we'll do both internal and external authentication, right? So we'll first configure internal authentication. We will see how we can create user accounts on the local firewall. And then we'll also go with external authentication. We will install an authentication server, create user IDs and passwords there, and then integrate that external authentication server to the firewall, right? So to create internal user accounts, you have to log in to your firewall through ASDM. So once you log into firewall from ASDM, go to configuration, right? Go to configuration. Instead of the firewall configurations, you'll have to go to the tab device management. So to create local user accounts, instead of the firewall tab, you have to go to device management tab, right? You'll have to go to the device management tab. So in the device management tab, you will see users and AAA. So go to that users and AAA, click on user accounts, click on user accounts in the users and AAA, right? So once you go to users and AAA, here you will have a user account which is predefined, right? So this user account is named as enable underscore 15. Now, if you recollect, when you are configuring your router, you are giving a command enable, you type the enable password, and then you put the privilege mode. Without typing the enable password, you will not be able to go to the privilege mode, or you will not be able to view the configurations or anything. You guys recollect that enable command? Guys, when you're configuring the router, you remember you give the enable command. So that enable is not just a command, enable is also a user account, and that's a default user account on your Cisco device, be it a router, be it a firewall, be it a switch, right? So this enable is the default user account that is already present on the Cisco device, right? So here there is this user account enable, right? So we are not going to make any changes to this user account. Let it be as it is. So what we do is, along with this enable user account, let us create some new user account which we will use for internet access. So click on the button to add a new user account. So let me say I'll give a username as user1, password as user1, confirm the password as user1, say OK. So I'm not disturbing the existing enable user account, it is still present. In addition to it, I have added one more user account called user1. Right? So this user account is present on the firewall. So whatever the user ID and password that's present, right, is stored locally on the firewall itself, right? So this is a local user account. Now we will see how do we enable the authentication part, right? So once you have the username and the password created, next we will see how do we enable the authentication. So to define authentications, go back to the filter tab, right? So here on the left hand side, go to the filter tab, right? Go to AAA rules, go to AAA rules, and here you will have to configure the authentication rule. So click on add authentication rule. So in the source, you can say source will be my LAN network computers. So we are saying if there is a request coming from any of our LAN network computer trying to reach something on internet, right? Trying to reach something on internet, then perform authentication. So we are telling the firewall, if you receive a request from internet, sorry, if you receive a request from any of our LAN computer trying to reach internet, perform authentication. Now, authentication should be done from which database? From the local database. So we said this authentication should be done from the local database, right? So local database means the user ID and password that is present on the firewall itself. So apply the configurations, right? So that what all configurations you have done will be sent from AHDM to the firewall, right? So it is already updated into the firewall, right? So now let us try to access internet and check what happens if we try to reach internet, whether will we be able to access internet or not, right? Let me see if my web server is up and running. Okay. So I'll try to access internet from my LAN computer. Now I should not have direct access to internet. Firewall should ask me what is the user ID and password. Only after authentication I should be permitted to reach this web page. So let us try to access the web page. So here, as you see, firewall is not letting me connect to the website directly. Right? So firewall is not directly permitting me to connect with the website. It is asking me what is the user ID and the password. Right? So let me give the username as user1 and the password we have configured is user1. I have the username as user1. Password is also configured as user1. Right. So once the username and password is given, let me say OK. Now firewall will verify the user. If that user account, whatever we have given, the login credentials, right? If those login credentials are correct, then firewall will permit us to access the web page. Right? So is this clear how we are going with the user authentication? So this is the internal user database, what we have used, right? So user ID and password is verified by the firewall itself within the local database. So what we'll do next is install the TechAxe application, create a user account on the TechAxe application, and then we will attach the TechAxe application to our firewall. We'll attach the TechAxe application to our firewall so that whenever user is trying to log in, whenever user tries to access internet, firewall will try to perform authentication using this external TechAxe server. Right. We will have to first install the TechAxe application. Now this TechAxe application is not a freeware, right? You will need a license to use it. But uh, as of our practical part, you can go with the trial version. You can use it. And anyway, in the current environment, right, on your live networks today, you don't need this third-party TechAxe servers and all those installed, right? So you'll have everything inbuilt, right? Or you can directly integrate it with your Active Directory. You don't have to go with a TechAxe server kind of thing here, right? So anyway, uh, once you install the TechAxe application, right, accept the license agreement, right, and then it will give you an option to start using the application. So once you are logging into the TechAxe application, it shows you what is the user ID and password that you can use for logging in to TechAxe. So the username is Super Manager. Super Manager is the username using which you can log in to the TechAxe application. And there is no password for this user account. So by default, you don't have any password for this user account, Super Manager, right? So, okay. And this information will only be shown for the first time, right? So when you're logging in for the first time, only then this information will be displayed. So from the second time, it will not show you what is the default username and all that. Right? So once the TechAxe application is installed, you have to start the configurations for the TechAxe application. And there are two things that you have to do in the TechAxe Plus application. First thing, you'll have to give a TechAxe key. So you'll have to define a TechAxe key. So this is like a authentication key between the TechAxe server and the firewall. Right. So the TechAxe key will act as a authentication key between the TechAxe server and the firewall. Right. So whenever you are integrating the TechAxe server with your firewall, your TechAxe server and firewall has to identify each other. They have to authenticate each other. So you'll have to configure TechAxe plus key. And then the second thing you have to do is create all the user accounts on the firewall, create all the user accounts on firewall and define this information to your firewall. So let us first configure the TechAxe key and then define user accounts. Then we will integrate it with our ASA firewall. Right. So to configure the TechAxe key, go to options. You'll see this TechAxe plus key. So let me say I'll give the TechAxe plus key as ABC1234. So the same key has to be given on the firewall also, ABC1234. Right. Only then the TechAxe server application and the firewall can authenticate each other. Say OK. So once the TechAxe key is given, next start configuring user accounts. So go to user, click on add user. So here you can give the user accounts. So let me say I'll give a user account as tag1, password as tag1. So give the username tag1, password as tag1. And I say this is a normal user account. This is not a super manager or an admin. This is a normal user account. Right. Say add. Then if you want, you can keep on creating multiple users, like say tag2. I'll give a password as tag2. So you can keep on creating multiple user accounts based on your requirements. Say OK. So once the user IDs are created, you can say save the user database. So you have created the TechAxe key, then you have created the user accounts and you have saved them. Right. So once all this is done on the TechAxe application, then the next step is integrate your TechAxe application with ASA firewall. That's the second step. So go to the AHDM application. In the AHDM application here, you have to say under device management, right? Under device management, earlier where we have created the user accounts under AAA and users, here we'll have to define AAA server groups. We'll have to define the AAA server group. So create a new server group. So let me say I'll give the name as TechAxe group. So I'm giving the name as TechAxe group and I say the authentication protocol used is TechAxe Plus. Right. The authentication protocol used here is TechAxe Plus. Say OK. So if you observe, we have only said what authentication method will be used. Did we say what is the IP address of that TechAxe server? So as of now, we did not define the IP address of the TechAxe server. We have only said what is the authentication method that is used. Right. So what we do is below this, you get an option to add the TechAxe server IP. So I'm saying on the LAN interface on this IP address 192.168.10.10, there is a TechAxe server installed. and the TechX key is ABC1234. The TechX key is ABC1234. So that is the TechX key. So we are defining the TechX key and also the IP address of the server. Say OK and apply. So you have said that there is a group called TechX server group, and in that TechX server group you have also defined the IP address of the TechX server, where exactly this TechX server is present. So now we will go back to the authentication policy and say try to perform authentication from external servers. So in the AAA rules, you already have a authentication policy. All you need to do is, instead of taking authentication from the local database, you have to tell the firewall, take authentication from the TechX server group. Take authentication from the TechX server group. Say OK and apply. So now what happens? Whenever end user tries to access internet, firewall will ask the end user to provide a user ID password. So once the user ID and password is given, that information will be sent to the TechX server for verification. So the user ID and password information will be sent to the TechX server for verification. So firewall will not do the authentication locally. So now let me try to access some web page. Okay. So as you see, firewall is asking me what is the username and the password. So I say username is tag1 and the password is tag1. So this is the user ID and password that we have created in the TechX server. So I say OK, and then I'll be able to access the web page. Right. So now I am authenticated using the user ID and password that we have created on the external server, on the TechX server. Right. Is it clear how we are going with the external TechX server authentication? See, when it comes to which method is better, it depends. See, you cannot always say use authentication or use IP address based policy. And again, if you say authentication part, it depends on the requirement, whether it is uh, internal or external. You'll have to decide it based on how many user accounts you have to maintain. Small number of user accounts, internal will do. Large number of user accounts, external is recommended, right? And in some networks you don't even go with the authentication, so it depends on whether you need authentication or not, depends on your organization security policies. Okay, so there is nothing like uh, this is good or this is bad. Yes, when you say passwords are static, but how would someone know the password unless the password is shared? See, here the thing is, when user tries to access internet, firewall is asking them what is your user ID and password. So what would the end user feel? The end user, who is, maybe they are good in their part, like their programming or their marketing or whatever it is, right? The moment they see a login prompt asking that type your user ID and password, will they understand that whatever activities they try to do or whatever they are trying to access is being monitored? So when end user knows that whatever activities they are trying to do are being monitored, will they try to do something stupid? Because obviously there is a sense that, see, even if I try to do something, right, my activities are being monitored by the admin team, right? Of course, except the admin team, no one else knows this, right? So if someone has to misuse, it should be someone from the IT team or from your admin team. A normal end user will not be able to bypass this or misuse this. So no issues. And of course, if end user is sharing their user ID and password with others, right, then obviously you will be able to catch them, right? Because you will also be collecting the logs, right? So when you collect the logs, you will see which user is browsing internet, right? From which IP address, right? And from which user account this internet access is being done. So accordingly, you can also do your further investigation. Why so and so user is accessing internet from two different IP addresses, right? So when this thing is going on, obviously, uh, the end user will be much more careful. Even if they have an intention of sharing the user IDs and passwords, they will not do that. Is it clear? So now we have done this authentication. Then at the same time, let us also do logging, right? Because if you want to see what's happening in your network, which computer from your network is trying to access internet, how long they have been accessing internet, or how much data they have been using, right? Or what kind of services they are trying to connect with, what is the destination that they are trying to connect with, right? What websites or what servers they are trying to connect with, what services are they trying to use more, right? So in that condition, if you have to monitor all these activities, you will need log messages, right? So log messages are nothing but simple records of information, right? On who is accessing what or which computer is trying to connect with what destination or what resource, right? So you can ask your ASA firewall to create log messages for each and every connection that is passing through the firewall, right? So ASA will create log messages for each and every connection and then display all those messages. But there's a small problem here. Even though ASA firewall is trying to create log messages and show you, it does not have the capability to store log messages. ASA firewall can create the log messages. You can temporarily view them, right, if you want, but you will not be able to store the log messages. Now tell me, as a administrator, should you also be storing the log messages? Should you be saving the log messages? You should be saving the log messages, right? Not only for your inspection, but even if you are going with any kind of audits or complaints procedures, you will need all the log messages to be saved, right? So as I said, your ASA firewall does not have the option of storing the log messages locally. You will use a protocol called syslog protocol. You'll be using a protocol called syslog protocol, using which you will be able to send all the log messages to an external server. Right? So in the syslog protocol, you are going to have two components, a syslog client. So syslog client is the one who generates log messages. Right. So syslog client is the one who is generating the log messages. And then you have a syslog server who is collecting the log messages. So tell me, in our example, what is ASA? Is it a syslog server or is it a syslog client? So ASA firewall is going to be a syslog client. It is generating the log messages. Syslog server is going to be an application which is installed on your computer. So syslog server is a application that is installed on your computer. ASA firewall is going to be the syslog client. So here you'll install a syslog server on your computer and then tell the ASA firewall on my LAN interface on so and so IP address, I have a syslog server. So now your ASA firewall will start sending all the log messages to that particular IP address. ASA firewall will start sending the log messages to that IP address. The syslog server will receive all the log messages. It will capture all the log messages and store them. Okay. So syslog server only has one job: receive the log messages and store those log messages. Right. So we will install the syslog server. So you can use any syslog server, need not be the same Kiwi syslog application, right? So you can install any syslog server application, it will work. So I've installed this syslog server, right? And syslog works on UDP port 514. Syslog works on UDP port 514. So your ASA firewall has to send log messages to the syslog server on UDP port 514. So once the log messages are sent by the firewall, this Kiwi syslog application is going to receive all the log messages and store them. So it is saving all the log messages in this location. We can see that in the log to file, C program files, syslog D, logs, syslog catchall.txt. Right. So syslog catchall.txt is the file name in which all your log messages are being stored. Say okay. So if you see, as of now, we are not receiving any log messages, even though we have the syslog server installed. As of now, we are not receiving any log messages. So what could be the reason why we are not receiving the log messages? So simple, as of now, you only have installed the application, but you did not configure the syslog option on the ASA firewall. So you did not tell the ASA firewall to send all the log messages, right? So that's the reason, even though you have syslog application installed, you are not seeing any messages here. So let us define that in the ASA firewall. So here we will say in the device management. So in the device management, we will say create log messages under logging option. Right. Under the logging option, I will say to create the log messages. Right. So go to logging, syslog servers. So in the syslog servers, you have to define what is the IP address of your syslog server. Right. So here let me say my syslog server is reachable via LAN interface. It is on this IP address 192.168.10.10, and I say that uh, port number 514 UDP has to be used for sending the log messages. So I'm defining all the details. Say OK. Apply. So we have said on so and so IP address I have a syslog server, right? Then you should also say logging has to be enabled. So you have to tell the ASA firewall start generating the log messages, and in the logging filters, right? In the logging filters, you say enable all the debugging messages to your syslog server. So send all the log messages to the syslog server. And if you see, as of now, uh, I'm not receiving any log messages, but the moment I say apply, I'll start getting the log messages, right? So as I said, send all the log messages to the syslog server, right? Now ASA is sending me all the log messages. Now let's say I'll try to access internet. So as usual, because I have not been active for some time, my authenticated session is lost, right? So now here firewall is asking me to authenticate. So I'll try to authenticate with say user account tag 2, which is a user account created on the external server. Say okay. I'm able to access the web page and see here. As of now, I have got some 1100 log messages. And if you see, I have only accessed one web page from one LAN computer. I have accessed only one web page, and as of now, I have some 1200 log messages. Now, let me say I also want to access some other website, say maybe hp.com, Microsoft, or Cisco, or something. So as you see, once you start accessing some websites, you'll start getting more and more log messages, right? And your syslog server will start accepting all the log messages, and it will keep dumping it onto the log file. But let me ask you a simple question. As of now, I have only one computer in the LAN network, and this computer is only trying to access one web page, right? And so far, I have some 1300 log messages. Now, what would be the condition if I have some 40 or 50 or 100 computers in the LAN network and they are all trying to access internet? Can I say I'll be getting some thousands of log messages every second? I'll be getting some thousands of log messages every second. So if that is the case, even though administrator is able to capture all the log messages and save it on a log file, will it be possible for the administrator to go to each and every log and see what actually is happening there? So even though administrator is able to collect all the log messages, it's practically an impossible task to verify the log file and see what each and every computer is trying to do, right? Or what each and every user is trying to do, right? So when you have some thousands of log messages coming in, it's not going to uh, it's not going to be an easy task for admin to verify what is happening there. So in such condition, does it even make sense collecting all the log messages when administrator is not able to verify all the logs. So guys, what do you say? If administrator is not able to read and understand all the log messages, do we really need to collect all the log messages? So we cannot say no. We have to collect all the log messages, right? But we have to see how do we analyze the log messages, right? We should see what can we do to analyze the log messages, right? So we should not stop taking the log messages, but we have to see if there is a possibility for us to analyze those log messages which we are collecting. And luckily, you don't have a problem here, because like how we are installing some third party applications to perform user authentications, to perform URL filtering and all, you also have some third party applications which will analyze log messages and tell you what is happening in the network, right? Because ASA does not have this capability to store all the log messages internally and all, right? Obviously, you don't even get a option to do the log analysis, right? So even log analysis is not available within the ASA firewall. So what you can do is use a third party application which will do the log analysis and tell you what is available, or what is actually happening in the network. So we'll have to install another software, some another third party software, which is a log analyzer application. So here I can install an application called FireGen. So this FireGen is a third-party application. It's a log analyzer application. Again, this is not a free tool. This is a commercial tool. You will need to purchase this. So once the application is installed, let us run this application. Still trying to start the application. Okay, so as I said, FireGen can be used as a trial version, right? So this is how you have the user interface of this FireGen application. Once you have collected all the log messages, all you need to do is go to the log profile and browse the location, right? You'll have to browse the location of the log file. So you'll have to say where exactly the log file is available. Now, when you are trying to import a log and try to do the analysis, make sure that you have some proper data on the log, right? So as of now, in our case, we only have log messages created from one computer, so you'll not really get anything in the analysis report. So what I'll do is, this application has a sample log file. The FireGen application has a sample log file. So I'll try to do the analysis of the sample log file itself instead of the log what we have created now. So let it do the analysis. It will open the result on a web browser and show you the result. Now see, in the initial days of firewall technology and all, how complicated things are. But now with today's newer generation devices, you don't have all these problems, right? But with the initial days firewall technology, because things are not inbuilt, this is how you have to do everything manually. So not only purchase and installing a firewall, you should also purchase so many other modules which are also required, learn how to do the configuration and also maintain them, right? Only then your network will be properly functional. So as I said, FireGen will give you the report in your web browser. So this is how it says. It says it has collected log messages from 192.168.7.1. Now that 7.1 is the IP address of the firewall where the sample log file has been taken. Now this is not our firewall, right? Now it says it has done analysis of a total of 3,877 connections. 182 MB of data traffic was found, right? So 182 MB of data traffic was found in this log analysis, right? Out of this 3,800 connections, some 915 connections were denied, right? 915 connections were denied by the firewall. It is giving us this kind of information, right? Now, when I see from inside to outside what kind of URLs have been accessed, so your inside computer or your LAN computer is something like 172.31.156.113, right? And this IP address is trying to connect with a FTP server on this IP, some 162.42.241.101. Then some other LAN computer 156.90, it is connecting to some other FTP server. So it is showing you the details like from your LAN computers, which are the source IP addresses, right? What are the source IP addresses with the highest number of outgoing connections, right? You can say like top internet using computers, whether it is for FTP or HTTP, HTTPS, whatever service it is, the top users. Okay. And it also tells you like what was the protocol they are trying to use and what is the destination that they are trying to connect. Right. So like this, you are going to get the information. And in the same way, it is also telling you from outside to inside, that is traffic coming from internet to your local network. So from which IP address on internet you are receiving the most traffic, right? So not only traffic that is going out of your network, it also tells you what are the top hosts from which you are receiving the traffic. So from which IP address on internet you are receiving the traffic, you are also able to see that, right? So this is how you have to collect log messages, and then you'll have to use a separate application to perform the analysis. So is it clear how you are trying to collect the log messages and how you are trying to do the analysis using some third-party tools? So guys, is it clear how log messages can be collected and how they can be analyzed? Now, all this thing is a manual activity, right? So everything has to be done manually, collecting the log messages and then analyzing them using a separate tool. Now, when you go with the newer generation devices, you don't really need all this. Right? You'll be able to collect all the log messages, store them within the firewall itself, and also it will automatically do the analysis and show you the report. Right. So that's with the newer generation device. So that we'll see in our next sessions. Right. So when you speak about this firewalls, not only trying to collect the log messages or analyzing them, you will also be able to host your own servers, right? Now, so far, when you speak about the NAT configurations and all, what kind of NAT configurations did we do on the firewall? So, guys, what kind of NAT did we do on the firewall? So, we are using PAT or port address translation, right? So, PAT will be helpful for outgoing connections. So, if you have to translate request coming from your LAN computers trying to reach internet, you will be able to use PAT or port address translation. Now, what if you want to host servers? Can we use PAT for hosting server? So I want my company's website to be hosted so that internet users will be able to access my company's web page. So can I use PAT, port address translation? So we will not be able to use that, right? So PAT is only for outgoing traffic, right? So PAT does not work for incoming traffic. So when you are hosting some servers, you are expecting incoming traffic. Traffic is coming from internet to your local network, right? So PAT does not work in that case, right? So for that we need different kind of NAT configurations, right? So for accepting incoming traffic from internet, we have two different type of NAT configurations. So let's say, for example, in my LAN network, I'll take up a server. In the LAN network, let me say I'll take up a server, some 10.200, where I have a website running, right? I have some 192.168.10.200 where my website is configured, where my company's website is running. Right? Now I want to host this uh, website to the internet users. Right? So any user on internet will be able to access my company's website, see the content of the website and all. Right? To do that, as I already said, as of now, our PAT or port address translation will not be helpful because PAT is only for outgoing connections. It does not handle incoming traffic because when there is a server, we are speaking about incoming traffic. We are not speaking about the outgoing traffic. So in such condition, we need a different kind of NAT called static NAT. So have you guys come across static NAT? Did you see static NAT in your CCNA? So if you are speaking about incoming traffic, so there's a user computer somewhere and this user wants to access our website. So this is incoming traffic. So for this, you are going to configure something called static NAT. So this static NAT is a one-to-one translation. One private IP address will be translated using one public IP, right? So one private IP address will be translated using one public IP address in the static NAT. And static NAT is also bidirectional, means it works for outgoing traffic and also works for incoming traffic. Right. Static NAT will translate outgoing traffic, that is the private IP address of your web server will be converted into a public IP, and at the same time it will also work for incoming traffic coming from internet to a public IP address will be translated to your server's private IP. Say for example, if I take up my web server's private IP, right? If I take up my web server's private IP as 192.168.10 dot say 200, right? 192.168.10.200 is the private IP address of my web server. Right? For this private IP address, I will use a public IP for translation. So for hosting this private IP, I'm going to use a public IP for translation. So let's say for web public IP, I'll take something like 206.182.201 dot say 124. Right. So I'm going to use 206.182.201.124 for translating the request. So here what happens when request is initiated from 10.200 trying to reach internet, that request will be translated using 201.124. At the same time, someone on internet, some user on internet, if they try to reach 201.124, that request will be translated to 10.200. Right. So the incoming request for 201.124 will be translated to 10.200 and request initiated from 10.200 will be translated to 201.124. Okay. So is it clear what is happening in the static NAT? So you can also call this static NAT as a bidirectional map. You can also call it as a bidirectional map, right? So it works on both the directions. So let us see how we can configure this on a ASA firewall. So let me just check if my server is up and running, and then we'll start with the configuration. Okay, so as you see, when I try to reach 192.168.10.200, I'm able to access this web page, right? So it means my web server in the local network is up and running, right? So now I have to configure static NAT for this IP address on the ASA. So to do the configuration, we go to the firewall settings. In the firewall settings, we go to objects, network objects. So in the network objects, I have to create two objects for defining this static NAT. The first object is the public IP address, what we are going to use, and the second object is a private IP address. So let me add a new network object. So I'll name it as, say, web public. So as per our example, 206.182.201.124 is the public IP that I'll consider. So I'm defining 206.182.201.124 is the public IP address. Say OK. And then add another network object, which is a private IP. So let us call it as web private. So web private is our inside IP, that is 192.168.10.200. I'm defining the inside IP 192.168.10.200. So once it is defined, expand the NAT section. Expand the NAT section. Enable the checkbox, add automatic address translation rule. Enable the checkbox, add automatic address translation rule, and the translation type is already given as static, so you don't have to make any changes. In the translated address, you select the public IP object what we have created now, which is web public. Say OK. So we are selecting the object as web public. Go to advanced settings. Select your source interface as a LAN interface, destination interface as a WAN interface. Say OK and apply. So now we have done the static NAT. So you can see in the NAT, you have two rules created. One policy for your web private trying to reach internet. The second policy for anyone trying to reach the public IP, that request should be translated to the private IP. Right. So we have done the static NAT configuration. So will I be able to access this website from internet? Our internal website, right? Will I be able to access it from internet now? So guys, what do you say? So let us try this. So from the external computer, right? I'll try to reach this IP of 201.124 and see if I can access the web page or not. So 206.182.201.124. As you see, even though we did static NAT, we are not able to access this web page from internet. The reason why we are unable to access this website from internet is because we did static net, but did we apply the security policy? Did we write a security policy saying traffic from internet should be accepted? Because when you speak about traffic coming from internet, traffic is hitting your firewall on the WAN interface, right? And the security level for WAN interface, we have given it as 0. And where is the server? It is in our LAN network. So here you have some traffic coming from a lower security zone trying to access something on a higher security zone. So will the firewall permit it? Traffic from lower security zone to higher security zone? So lower security zone to higher security zone, firewall will not accept the traffic, right? So what we have to do is to permit this incoming traffic, we have to write a security policy saying this incoming traffic has to be permitted, right? So we'll have to say the incoming traffic should be permitted. Okay, sorry, on the WAN. So on the WAN interface, I say traffic should be permitted, right? On the WAN interface, I'm saying traffic has to be permitted. Traffic coming from any source IP, because we do not know from which IP address end user might access our web page. So we say traffic coming from any IP address on internet trying to reach our web server, right? So I'm giving the web private IP object because on the web private, you have done the translation. For 10.200, we said translation should be done. So I'm saying if request is coming to our web server, for what service? For HTTP service. So depending on your server, if you are running HTTP, select it as HTTP. If you are running HTTPS, select it as HTTPS and apply. So once the security policy is written, now from external mission, we can check here. As you see, now this website is accessible. Okay, so once the static NAT is configured and also your security policy has been configured, internet user will be able to access your server. So is that clear? So guys, is it clear what is static NAT and how we can use static NAT? Guys, are you clear with static NAT configuration? Am I audible, guys? Can you hear me? Okay, so did you understand what is static NAT and how we can write static NAT policy? Okay, so static NAT can be used for hosting your servers and all, right? And then permitting internet users to access your servers, right? So PAT or port address translation will not be helpful for accepting incoming traffic. So you'll have to go with static NAT and also write a security policy there, right? So there's one more NAT configuration, right? Uh, Port redirection NAT. We'll discuss that in the next session. But before we end today's session, let me show you how you will be able to configure the VMware interfaces for your firewall labs. So here, I share my system. So earlier we were using VMnet 0 for our ethical hacking part, right? So we were using VMnet 0 interface for our ethical hacking part, right? And we have bridged this VMnet 0 interface to our existing Wi-Fi or Ethernet, right? To our existing Wi-Fi or Ethernet, we have bridged the VMnet 0 interface. Do you guys remember this? So you remember doing this configuration, right? Now, when you speak about the firewall practicals within your VMware, you will be having two virtual machines. So earlier we were using one virtual machine, right? And even if you go with the second virtual machine, they are all directly connected to internet, so VMnet 0 can be used. But here, when it comes to the firewall practical, you will have two virtual machines. One is your firewall with two interfaces, a WAN interface and a LAN interface. Right? So be it ASA or be it Storm Shield, you will have two interfaces, LAN and WAN. And then you will have a second virtual machine which is a client. Right? The second virtual machine is your client. Right? And this client will have only one NIC card. Right? Only one interface will be there, which is a LAN interface. So here basically, how should we have the connectivity? Should the firewall connect to internet? So guys, should the firewall connect to internet? So firewall has to connect with internet, right? So the WAN interface of the firewall, you select it as VMnet 0, the adapter which you have already created earlier. Right? So nothing to be changed for the firewall WAN interface. Now for the firewall LAN interface and the client computer, we have to define another network adapter in VMware. Same as how we have defined VMnet 0, we have to define a different adapter VMnet 1. Right. Now this VMnet 1 should be a host only adapter. Right. So earlier I've shown you when you are creating network adapters in the virtual network editor, when you create a new adapter, by default, that network adapter will be configured as host only. Right? So let it be the host only adapter. VMnet 1, when you add a new adapter, it shows as host only. So let it be as host only. No need to change that. On the firewall virtual machine, the LAN adapter will be VMnet 1. The client computer's network adapter also will be VMnet 1. Right. So the firewall LAN adapter will be VMnet 1. The client computer's network adapter also will be VMnet 1. So now, how is the traffic flowing? Whenever there is some request initiated from LAN computer through VMnet 1, it is coming to the firewall's LAN interface, go through your security policy, go through your NAT, and then via WAN interface and VMnet 0, it goes to internet. Is that clear? How is the traffic flow from the client virtual machine to internet? Okay, and regarding the IP addresses, right? So for the firewall LAN, you can take the same LAN IP segment as what I'm using in the sessions. You can take something as 192.168.10/24. And for the WAN, you cannot use the public IPs what I'm using here in the uh, lab, right? Because those public IP addresses will not be available in your network. So what you can do is on the firewall WAN, you can take a IP address in the same network as your Wi-Fi. So on the physical computer, on your Wi-Fi, whatever the IP address you are having, right? You can take a IP address in the same network. Now let's say your computer's Wi-Fi has say something like 192.168.0.20 or 0.30 or something. On the firewall WAN interface, you can take something like 192.168, say 0.25, right? You can take it as 0.25, right? And for the firewall default gateway, it will be the IP address of your home router, which is going to be something like 192.168.0.1. Right. Is it clear what kind of IP addresses we have to take? Okay. So use this IP addressing, right? So you got an idea. So try to use the IP addressing and start your ASA VM also, right? So if you face some difficulty, let me know. Okay, so we have done with the static NAT configuration, right? So the next session, we will also do something like port redirection configurations, right? We'll do port redirection NAT, and then we'll continue with the Storm Shield UTM. Okay, thank you all.